So hi everyone, my name is Ritika Goswami and in today's video I'll talk about what is normality. Okay, so first things first, before developing a good understanding of normality, we'll just first brush up our skills on what molarity was, okay, and how those two are different is going to be what our end discussion is going to be about today. We will also discuss a little bit about dilutions and maybe a question here and there, okay. That's what is going to be our itinerary for today. So let's begin, right? So, as I said, we'll first talk about molarity because why not? Okay. So, in a very basic or a very layman language term, I can say that molarity is a unit measuring concentrations in chemistry, and it talks about the strength, okay, in solutions. So if I just talk about, let's say, a 1 molar solution of anything, that will basically mean that 1 mole of that anything into 1 liter of solution. So let's say if I have a 2 molar solution, it means 2 moles of that solute in 1 liter. If I have a 3 molar solution, it will mean 3 moles of that solute in 1 liter, okay, and so on and so forth. So very basic, whatever is the number of moles in 1 liter, that is going to be the molarity of the solution, and that basically gives us this formula, a very basic one, that molarity equals to number of moles, which we know how to calculate apparently, right, divided by the volume of solution. That is all, okay. Because all the time we can't have 1 liter, we might have 250 ml, or because we don't, in chemistry labs we actually don't, have those 1 liter things all everywhere, and that's also not comfortable. So I hope we have a very clear understanding of molarity, okay. Now now let's cut to the chase here, okay. So if I talk about normality, okay, this is the formula that I get everywhere, okay, in your textbooks, or if you just go and search into Google. The formula of normality that you will get is what looks like this. We have number of equivalents, we also call them gram equivalents, okay, divided by liters of solution. Now this number of gram equivalents is something which is different, because in my molality case the numerator was number of moles, denominator in both cases is the same, it is the volume of solution in liters, which is okay, but numerator is something which has changed. In terms of molarity, it was number of moles, whereas in this it is changed into something called equivalents or gram equivalents, okay. Now let's try to understand what is this term which is equivalence, because and how is it different than number of moles, okay. So before cutting to the chase, I will give you a conclusion, okay, and we will just see how this conclusion works later. But the conclusion is that normality, okay, will, and don't quote me on this, okay, will tell you about the truth of any solution. Now let's see how and in what way will the truth be looking like, okay. But molarity in some cases might not actually tell you the truth concentration or truthful concentration, and in some cases it will tell you also, okay. We'll discuss what those cases are, but normality will actually talk about the truth, the blunt and point blank truth. Now let's see why and let's see how. So let's say we have HCl, and we know HCl is a very strong acid, okay. So HCl, because it is an acid, it will just break down into, oops, I just jumped to the next slide. So it will just break down into H positive and Cl minus, and that is very common behavior to acids, right. So 1 mole HCl will break down into 1 mole H positive and 1 mole Cl minus, and that is what is expected, okay. But if I have another acid which is H2SO4, in this case this dissolution will not be this simple, because in the first step it will be H plus and HSO4 minus, but there will be a second step in which we have again an H plus and SO4 2 minus, okay. So what is different in this case? 1 mole of H2SO4 is going to give me 2 times H plus ions than you are expecting, because we only have 1 mole H2SO4, but in that 1 mole we get twice H plus, because here it is a diprotic acid, right. So in this case the truthfulness factor, which also is known as the N factor, which is actually truly known as the N factor, that is the bookish language, okay. So the N factor here is 2, okay. So in this case, molarity will not be the same as normality. Why? Because moles of H2SO4 is 1 only, okay. But the actual term, in the actual way, it is giving out 2 H positive ions. So that's why in this case, specific to H2SO4, where the N factor becomes 2, okay. In this case, normality will be equal to 2 times molarity, okay. So in case of H2SO4, molarity, if let's say molarity is 2 molar, normality is going to be 4 molar, and that is the truth of H2SO4. 2 molar H2SO4 is not the same as 2 molar uh, 2 normal H2SO4, okay? But whereas if I talk about HCl, okay, here one HCl is going to give me one H positive and one Cl minus because it is not diprotic, okay? Here the N factor, as we know, is 1, okay, and because the N factor is 1, there is no difference, okay, and in this case the normality is going to be equal to molarity because there is no truthfulness factor here, right? So now I hope we are clear with what is the difference between normality and molarity, okay? This gram equivalence is nothing but moles multiplied by the N factor, okay? So there are different ways to calculate this N factor, which we may talk about it later because that will be a lengthy video, but I hope we understand how is moles different than gram equivalence, okay, and in what cases they both will be same, of course where the N factor is 1, and in what cases they both will be different, okay, of course where the N factor is not equal to 1. Okay, so moving on, we have the next part, which is talking about dilutions, okay. So just a very vague example, let's say you have a very concentrated solution of uh, not solution, concentrated orange juice, okay. So what do? You want to drink it, but you cannot because it is very concentrated. So what happens is you just add a little water into it, and now because it is dilute and better tasting, you are able to take it, okay. So this, what you did, is called dilution. Dilution means addition of water, okay. So let's try to understand this picture right here. So on the left hand side we have a jar in which we have 11 moles of anything, just let's say anything, okay. I'm actually writing anything here. Now we want to add a little water to dilute this, okay. So we just keep on adding water, and now we have more water. Initially we had this much water, now we have this much water, okay. But in the LHS or and the RHS, okay, did the number of moles change? No, because we didn't actually take out the 11 moles from there. Initially also we had 11 moles, and now also we have 11 moles of that anything, but now we have much more water, okay. But the main point being that the moles on the left hand side equals to moles on the right hand side, and obviously now we know how moles and N factor, is different and is same, okay. So of course if the moles are equal, of course the gram equivalence will also be equal, right? Because here the thing is not changing. If we have 11 moles of A on the left hand side, after addition of water, it will be 11 moles of A and more volume of water. The component A will not change, okay. So of course the gram equivalence will also be the same. So if the moles is same, the gram equivalence also on the both sides is going to be equal to same. On the LHS should be equal to gram equivalence on the right hand side. That is done, okay. And we know the formula for moles and the formula for gram equivalence, okay. So we have normality equals to gram equivalence divided by volume. So just a simple cross multiplication, we have N1 V1 should be equal to N2 V2. What does this formula suggest? Basically the gram equivalence on both sides are the same, and hence the moles on both the sides should be the same. That is the basic understanding and nothing else, okay. So on this we'll just practice one question and then we'll call it a day. So now we have a question which says you have 0.5 normal HCl solution in lab. Now here the term normal is a little confusing because, well, you could have easily said 0.5 molar, because in this case, in case of HCl, molarity and normality are exactly the same because N factor is 1, okay. Alright, so you have 0.5 normal solution of HCl, okay, great. You need to prepare 250 ml of 0.1 normal HCl solution. So final solution is what? Final solution is 250 ml. So this is my V2 obviously, and final normality is given to you as 0.1 normal, okay. And obviously this is my initial normality. That is very fine. How much water will you add and how much 0.5 normal solution? Very easy, okay. A simple case of N1V1 equals to N2V2. Let's put it. So we have N1V1 equals to N2V2. 0.5 into V1 equals to 250 ml into 0.1 normal, okay. If I just cancel the units on both sides, okay, the V1 comes out to be 50 ml. So if I have to say it out loud, basically it means that I will take 50 ml of 0.5 normal HCl solution and I will just take the volume up to 250 ml, and whatever solution finally I get is going to be a zero point 0.1 normal solution. How much water will be add? Very simple. We already took 50 ml, okay, and we want to make it 250 ml. So how do you make 50 to 50? You just add extra 200, okay? So you had extra 200 ml water. So this is the answer to how much water you need to add, right? So that is all about normality and dilutions and gram equivalence. And thank you so much for today.